Okie doke, so let's work through a couple of word problems that deal with quadratics and factoring. All right, now this first one isn't going to have much quadratics in it. And you may say, well, what does that have to do with factoring? But it really kind of deals with the greatest common factor. So let's go ahead. We'll do 3 different questions. First one says, a sales clerk is organizing 24 pairs of shoes for a sales display. In what ways can she organize the shoes so that she has the same number of shoes on each shelf, using at least 4 shelves with at least 2 pairs of shoes on each shelf? All right, well, maybe that's a lot of information to take at once, but I do get that there's 24 pairs of shoes, and we're trying to organize the shoes so that there are the same number of shoes on each shelf. So let's start with that. Okay, so we can have shoes and shelves. So I can have one pair of shoes, on 24 shelves. I can have 2 shoes on 12 shelves, right? So I'm looking at the factors of 24. That's how this kind of goes in. I can have 3 pairs of shoes on 8 different shelves. I can have 4 pairs of shoes on 6 shelves, and then I can have the opposite. I can have 6 pairs on 4 shelves, 8 pairs on 3 shelves, right? And so I'm just coming up with the ways that I can get 24. Right? So 24 pairs of shoe on 1 shelf. All right, now what I'm going to do next is now look at the other information. So using at least 4 shelves, so at least 4 shelves, well, 1 is not at least 4, 2 is not at least 4, and 3 is not at least 4. So I got to have at least 4 shelves and at least 2 pairs of shoes on each shelf. Well, this only has 1 pair of shoes, and so I'm left with these 4 possibilities. And so that's it. Those are the 4 ways that she can organize. She can have 2 pairs of shoes on 12 different shelves, 3 pairs on 8 shelves, 4 on 6, or 6 on 4. All right, so there's some factors for you. Let's go on and look at the next one. The sales of a particular CD can be modeled by this given equation, where S is the number of CDs sold in thousands, and M is the number of months since the release of the CD. So A, in what month should they expect to stop selling the CD? All right, well, what does that have to do with this equation? Remember, S is the number of CDs sold, and M is the number of months. So it's asking in what month, therefore M can be our variable, and it says stop selling CDs. So what does that mean? Hopefully you figured out that that means that S, remember, S is the number of CDs sold. So if they stop selling them, that means 0 CDs. And so let's just say that S equals 0. So we can put 0 in for S in our equation. So we say 0 equals negative 25m squared plus 125m. And so from there, you can solve, right? We can go ahead and factor since it's equal to 0. What should we do? Well, first thing we always do when we're factoring is look for a greatest common factor. So looks like 25, and we talked about how if the leading coefficient is negative, we should factor that out too. So let's factor out a negative 25m, because both of them have an m as well, which leaves me with m, because if I divide negative 25 by negative 25, I get 1. M squared divided by m is m. And then plus 125. 125 divided by negative 25 is minus 5. And m divided by m, they cancel out. And so now I have 2 things that multiply together to give me 0. So equal either negative 25m equals 0 or m minus 5 equals 0. And so I divide by negative 25. And m equals 0. Which makes sense because after 0 months they shouldn't sell any CDs. Or m minus 5 equals 0, in which case I add 5. And so after 5 months you can expect to sell 0 CDs. Now, the maximum they will ever sell in a month is 156,250. In which month does this occur? So we can go ahead, we can plug that in for S, right? Because that's the number sold. Now remember, S is the number sold in thousands. So I need to write down 156.25 for S, and then say equals negative 25m squared plus 125m. And that way we can try to figure out what m is, because it's asking for which month does this occur. So what should we do? Well, we should subtract the 156, make it equal to 0. So minus 156.25 minus 156.25. So now we have 0 equals negative 25 m squared plus 125m minus 156.25. All right. Now at this point, what else can we do? Well, I do have a trinomial, which means I can factor it. We talked about before that if there's a negative in front, we just mentioned that, right? If there's a negative in front, we probably want to factor that out. So let's go 0 equals negative times 25m squared minus 125m plus 156.25. And so from there, the question is now, how do I solve this quadratic? Well, we solve this quadratic by either factoring or using the quadratic formula. What I see when I look at this is I see a 0.25, right? That's a quarter. So what I'm going to do is I'm going to multiply everything here by 4, because if I multiply by 4, that's going to give me 100m squared minus 500m, because 4 times 125. I'm going to do it to this side, and I'm going to do it to that side, right? So this is still 0. 100m squared minus 500m. And then if I multiply this by 4, then I'm going to get 156.25 times 4, and I get 625. And now what I see is I see 100, I see 625, right? Is there a common factor? Well, I think I can divide everything by 25. If you don't recognize that, maybe divide everything by 5, right? But I know I can divide these by 25. So I'm going to go ahead and do that. Just simplifying, right? I'm taking out a common factor. You could factor it from here. You could plug it into the quadratic formula from here. I'm just trying to come up with other ways of simplifying and working this out. If I divide everything by 25, which I can do, so I'm going to factor out of 25. So now it's a negative 25 in the front. I'm going to have 4m squared. 25 into 500 will be minus 20. And then 25 into that will be plus 25. Now at this point, I think I'm finally ready to actually factor it. So I'm going to have the negative 25. I need to break it up into pieces. Looks like I've got a 4m and an m. In order to get the plus, it's probably going to need to be minus and minus. All right. Maybe 4 and an m won't work now that I'm looking at it. So I'm just going to go ahead and change it to 2 and 2. You can try out the 4 and 1, but I can see already it's going to be 2 and 2. And then 5 times 5. And you'll notice that negative 5 times 2 is negative 10. Negative 5 times 2 is negative 10, which add up to give me the negative 20. So there we go. Now we can solve. Set negative 25 equal to 0. Which doesn't make any sense, so we'll get rid of that one, and set 2m minus 5 equal to 0. If I add 5 to both sides, I get 2m equals 5, divide by 2, and m equals 2.5. So in the middle of the 2.5 month, so I guess during month 3, that's when you're going to get the maximum. All right, so that was a little bit messy on the factoring part, but again, you could have stopped at this point right here. You could have used the quadratic formula, or, you know, you have a couple of different options there. I chose to try to simplify the quadratic so it was with workable numbers, and I factored out the common factor. That's fine too. All right, last one. Let's look at a park has a square shape with a total area of 121 meters. So it's a square, which means that it's the same length on both sides. The total area is 121 meters squared. The center of the park is a grassy area that's 6 meters across. All right, so here we go, 6 meters across, both side to side and up and down. The rest of the area is a uniform sidewalk that surrounds the grassy area. How wide is the sidewalk? Okay. Well, we've done things like this before, right? Really, we've got the outside and the inside. Okay, we know that we want the total to be 121 for the area. All right, so what I'm going to do, since it's actually asking for how wide is the sidewalk, I'm going to change my x's, and I'm going to make x be the width of the sidewalk. Okay, which is there and also here. All right, so how wide is the total park? Well, it's x across here plus 6 across the grassy area plus 6 for the rest of that, right? How tall is the park? Well, the sidewalk is x. It's 6 wide for the grassy part, and then x tall. And so if we simplify that, we got 2x plus 6 and 2x plus 6. Now, it says the area is 121. How do you get the area of a square? Well, we go length times width equals, so length times width equals the area, which is 121. And so now we need to solve this. Now, it's not equal to 0, which means we need to get it to equal to 0. But in order to do that, we're going to have to FOIL this part up here. So 2x times 2x is 4x squared. 2x times 6 is plus 12x. There's another 2x times 6, so another plus 12x. 6 times 6 is plus 36. So that's 4x squared plus 24x plus 36 equals 121. We'll subtract the 121 from each side. And now we've got 4x squared plus 24x, and then 36 minus 121 is 85. So minus 85 equals 0. And so now we want to factor this. All right, so I'm going to factor it up here. It's either got to be 4 and 1 or 2 and 2. So we'll make a guess. I'm going to guess that it's probably going to need to be 2 and 2. All right, so 85. 85 is 5 times 17. All right, or 1 times 85. That looks like it. So let's try with 5 and 17. I've got a negative, which means it's got to be a plus and a minus. So we know it's going to have to be positive in the end. So let's make the positive one bigger, the negative one smaller. So then we will FOIL. So 2x times negative 5 is negative 10x. 17 times 2x is plus 34x. Oh yeah, look at that. They add together and give me 24x, which is what it was supposed to give me. That is, of course, equal to 0. You'll remember down here. And so now either 2x plus 17 equals 0 or 2x minus 5 equals 0. We'll subtract the 17. You can actually stop right here because you know that you can't end up with a negative length. I'll finish solving it just because, but really at this point, this answer doesn't really make sense because you can't have an x that's negative. That's the length, the width of the sidewalk. And then the other one, we go plus 5. And we got 2x equals 5. Divide both sides by 2. X equals 5 over 2, or 2.5. All right, so there you go. That's the answer. Hopefully that works out for you. Check the next videos for a few more word problems.